I don't plan to do a chapter today. I wanted to do some demonstrations. Now, my original plan was to demonstrate 401 Ollie debug today, but we already did that a few weeks ago. Thought it looked familiar. I'll do 402 and we'll try 404. And if we finish that or it doesn't work, we'll move on to the .NET demos. That's my plan. So I got a Windows on ARM machine here, and I think I can do all this in Windows for ARM. So I'm going to try it here. I was surprised when I first found out I could do these Ollie debug projects in here, but apparently Intel code can run on the ARM machines. There is some kind of translation going on. I know it happens with Macs. Macs have a thing called Rosetta, which runs Intel code on an ARM processor, and Windows appears to have some similar thing running, although I've never heard a description of why it works. But I can download compiled Intel code and run it on the ARM Windows, which I guess is happening for quite a few of the apps I run.
So this eliminates those problems. So yeah.
Well, it's better. Now, some things, now if I write new programs and compile them here, I wonder if I could cross-compile them from Intel and run them here. Anyway, that's why I wonder. Some of these projects, I said you needed an Intel-based machine, and there may be ways around that. But anyway, the Ollie debug stuff does seem to work, so let's try that. So here we're going to get, all right, now we're going to get Python, and let's see, now Python is typically installed as part of Ollie debug, so let's make sure that works. If I just open a terminal, or I guess it's PowerShell, this is, I think the terminal is what this is, called terminal now in the latest version of Windows. If I right-click, yeah, they call this terminal. And by the way, the amazing thing is Control-C and Control-V finally work after like 40 years. They finally fixed it. So anyway.
But you should update the PowerShell because the default version gives some problems. The new version, the 7 version, I think is.
Yeah, well, this one has SSH anyway, which is the main thing I want. But yeah, but updating, good idea. Anyway, now let's, so I want to see if I have Python. And it's going to send me to the Microsoft Store, so that's annoying. So that means the Python installation is not working. Now it's on there, but where it is, it's C. If that doesn't work, you can give it the full path, which is C Python 27 Python. It's still not there.
Not in the bin.
Well, I thought it was automatically added when you installed Ollie debug, so this is the first issue. Let's find out what happened with Python. And this expanding isn't working for some reason. All right. Oh, there's no Python folder. Well, that's a problem. Okay. I thought it went on when you installed Immunity. And, oh, it looks like I've not installed Immunity. Oh, this is not my pre-made machine. This is my, this is a machine I had to install from scratch on the ARM processor. So Immunity is not installed. So let me do that. Come on, let's get rid of this garbage. Everybody has to put heads in the way. All right, how to install? Well, where's the download? What is this garbage? Releases? Download? Kbondla? It's not immunity.com? From all these weird places, is Immunity no longer available from an official website? All right, let me look at the instructions I have for installing your own machine and see where I got it. Over here I downloaded one big thing I made, a big file that included everything, but I also included links to Immunity. It's in here somewhere. There, Immunity Debugger. And that is, like I thought, immunityinc.com. Wow. Wow, that's interesting. Maybe there's no longer an official source for Immunity. Wow, looks like this company is dead. Well, now that's annoying. Okay, so you have to get the unofficial, well, all right, I'll settle for an unofficial installer. That's rude. So somebody cloned it, a repository. Okay, so there should be releases. Yeah, 1.85 is the one, I think. Well, that's interesting. Okay. Looks like Immunity is gone as a company. That's rude. I guess we should be using X32 and X64 debug. That's the modern alternative. But anyway, for purposes of this project, I'm going to install it because that'll put Python 2.7 on, And that's how I wrote the project, although I'm thinking I may want to update these projects to use something else besides immunity. But for a lot of my projects, you really need Mona, which is the plugin for immunity. So I'd have to find out how you do that on a more modern debugger. But see, that's the point. Python 2.7 is not there, and installing this will put it on. Okay, good. Accept. Well, that's interesting. It's been happening a lot to me this semester. A whole bunch of my projects things have changed, so I have to update them. So.
Catching up with the vulnerabilities.
Yeah, well, apparently I'm going to have to update all the immunity projects. So that's life. That's what makes this field so interesting, is everything keeps changing.
Keep dynamic, yeah?
Yep. And to be fair, I don't know if I don't think immunity had a pay version. I don't know how they made any money anyway. And there is x64 debug and x32 debug, so I guess there's no real reason for immunity to exist except for the plugins. And there's probably some version of the plugins for those other debuggers. So now stuff should be installed. Let's see if I open a new terminal window, if Python works now. It still sends me there. Let's see if there's C Python 2.7 Python. There, it's there. Okay, I can do it that way. And maybe when I restart the machine, the path will get fixed. More likely, it didn't install the path correctly, which is usually what happens with open source software. It never installs very well on Windows. So this is how you can get to it in a machine that has immunity installed. So I can get out of here. That's what I need. So this, I hope you're used to, a lot of students have the same issue. Most of the time is spent getting to step one in these projects. Getting a machine set up correctly is the hard part. So now I've got Python. Okay. And now we're going to get Minesweeper. So I'll just do it this way. Put it in downloads, and then drag and drop it in that other machine. I made a modified version of Minesweeper, which is a Windows XP game. And I did this because the hacking tool Metasploit, the cat, Mimi Cats, has Mimi Cats has a Minesweeper cheating feature.
But now it's not working anymore. It's been deprecated. There is
Something new instead, yeah.
The new one is Kiwi.
Yeah, but anyway, I saw it in Mimi Cats, and I realized, I checked to see how it worked, and that's what this project is based on, making a version of that. So here's Minesweeper. So I extract all, extract. All right, and there it is, the game Minesweeper. And this game, you can play it here. You click on things, and there are bombs, and this tells you where bombs are. Only one of those has a bomb, one of those has a bomb. And so you try to deduce from the numbers where the bomb is and fill this in. So you can play the game that way, and if you win, you'll see a flag. There's 3 levels of the game: beginner, intermediate, and expert, and there's a different flag at each level. So you could, in fact, win by getting to the flags, but we're going to cheat. That's no fun by actually playing the game. The interesting thing is how to cheat on the game. So now you see how it works. So
basically, we are hacking the RAM. Because
exactly.
The solution is in the RAM, right?
Exactly, yes. So let me get back up here. I want to have it running, and I want to have some shape to the board. So let me do this, and let me guess a few of these. Okay. Okay, so now I've got some structure. Now we're going to look at it in Ollie debug. So go to Ollie, and I could have launched it in Ollie in the first place, but now I can attach to the running game probably. File attach to Minesweeper. Okay. I'll attach to the running process. That's another way to do it. And now that's going to make it pause. All right, and now that I've done that, I should be able to just look at the RAM sections, view memory, and look at the mindslam.data line. So I view memory. Okay, and let's just make this big. And down here, somewhere, is the actual, there's the program. Because of address space layout randomization, it moves around. So let me use the mouse to move, or the keyboard to move in smaller increments. Now I could use, there it is, okay, it'll be somewhere random on your system. And you could use NT-DIL characteristics to make it stop moving, which we talked about previously. But anyway, it doesn't really matter where it is as long as you can find it. So you see, here's the segments. There are 4 segments. There's a header, text, data, and resources. And resources is static things like icons. Text is the code, and this is the data. So the data section is where you would expect to find the information about where the bombs are. So you dump that. All right. And now, if you just sort of page through this, and I wonder if I can do a page at a time. Yeah, I can, good. This looks pretty good right here. 10, 10, 10, FFF, and then I have 42, 40, and 41, and those are the number of bombs, 1, 2, and 3, sort of like that. So this is reflecting the state of the board, and you can even see the shape here is sort of right. And if I made this the right width, which I don't know if I can adjust it, might be able to. So it shows 16 in a row. I don't think, it's still showing 16 in a row. I think I need to show more than 16 in a row, but that's the map right there. So you can see where the bombs are. That's the idea. So you could, in principle, find the bombs by reading that display this way, but it would be a whole lot better to make an automated process. And so the way to do it is the sysinternals tools proc dump. This is the tool that will dump the process. Actually, one of my links doesn't open in a new tab, which is really old, but anyway. So I download this thing, and there it is. Wow, they made it for Linux and Mac. That's new. But anyway, I don't care about that right now. I'd like to make room on the desktop. There we go. All right. So now proc dump is here. All right. All right. And let's get to the desktop. Get this thing to move. Apparently not. All right. There it is. I think that's proc dump. There we are. Okay. So I right-click, extract all, extract. Okay. And there's proc dump. And in this case, I think I want proc dump 64A. That will be for ARM. So I'm going to put that on my desktop where Minesweeper is. So they're all in the same folder. That's going to be important to make this work. Okay, now let me close this tab. Okay, so now I'm going to create a Python script in whatever, I'm going to work in my desktop folder. I'm going to make cheat.py, and it's going to have this code, which is the Python 2 code to find the information from the memory and print it out in a better format. That's all this is going to do. So I'm going to get a command line and move to where the stuff is, which is desktop. If I do a directory, here's MineSam and here's procdump. Those are the things I need. Procdump64.exe. So now notepad cheat.py. Okay, make a new file, paste in the stuff. Okay, now delmine.dump. Okay. Now see, notice here, procdump mine. In my case, it's procdump64A. I probably have to fix that. There. And then that will make this will dump the contents of that program into a file called mine. This will now search for the game board, which starts with this pattern of bytes. And then it will go through that pattern of bytes and just print them out by taking the existing code and replacing it with like minus, space, star, and other characters, which will show me what's going on. So that's it. That's what I've got. Let me save this with file save and try running it. I wonder if I need administrator rights to run it. Let's try it without. So Python. Now I remember I have to give it the whole path for some reason. For some reason the path is not fixed, which is extremely common in Windows machines. Okay, cheat. Okay. So I run it, and now I have to agree to the terms. And there it goes, making a dump. Okay, and there it goes, printing out the board. So now that's the graphical image of the board. And this is the game image here, which for some reason is not coming to the front. There, okay. And so now I can compare these and cheat. I can see where the bombs are. These two bombs are here, not there.
So what bomb is between the two?
between
The asterisk should be the bombs.
yeah, the stars are the bombs, yeah. And for some reason, it's not moving. Let's see if I'm stopped. Yeah, I'm paused in Ollie Debug, that's why. I need to run it here. Okay, now the game is running again. All right. Now I should be able to play the game. I can see that the bombs are there.
So if you right-click on the bombs, you put a mark. And
That's right, you could do.
Over all of them.
Yeah, you could do that. Yeah, the twos here, the bombs are there, so nothing there, there. Yep. So yeah, so now I can win, and this one here is obviously the bomb, and none of this stuff. And anyway, so now you can see what you're doing. The only point is now you can cheat, and so. The first challenge is to win the game, which you should be pretty easy to do with that information. And then the intermediate level, you can do it, but you'll have to make your own cheating tool that works better because the board is bigger. So you have to modify that script. So look for a different mark and play it out differently. And then the expert level, you will not be able to solve it this way. Even if you cheat, I found it impossible to win that way. You had to think of another way to find the flag. So try some of the other techniques we've used to find the flag. Playing the game, I couldn't find any way to do it by playing the game. But you can still find the flag in the executable by using our other tools. So anyway, that's what I wanted to show you about this one. And I see no comments in the chat. Let me stop this recording.